So you are in your notebooks today. We're going to talk about this. We call this the speed chart. Okay? And we're going to work through the speed chart because this is the start of the trig with rotational things rotating and putting things into a circle. Okay? So the first speed that's out there is rotational speed. So rotational speed is on the outside of a circle. I'm going to use my nephew's old first bike to demonstrate for you. What I want you to focus on is I want you to focus on the valve stem right there. Okay? So if we're focusing on the valve stem, rotational speed is the amount of revolutions that valve stem is going around until it gets back to the same spot every single time over a certain amount of time frame. Okay? Obviously, the faster it spins, the more rotations that it happens. The slower that it spins, the less rotations that happens. Okay? But always going back to when it gets back to that same spot. Okay? That is rotational speed. It is measured in revolutions per time. The most common of those is revolutions per minute, RPMs. And that's the most common for rotational speed. Okay? The next one then is angular speed. So again, if we're focusing in on this valve stem, we're talking about the amount of angles that the central angles that it goes in. So really, we're watching the valve stem go around, but we're also drawing a line back to the center of that circle, or the axle at this point on this bike, and we're counting the angles that it's going through. So as it's going around, now we're talking about angles in angular speed. I know, it's crazy talk, okay? And so we're talking about that, and the one thing that we need to know is that in one complete revolution, there are 2 pi radians. Okay? So if you are, the conversion here is 1 revolution is 2 pi radians. If you are going from rotational to angular, then you would go 2 pi radians divided by 1 revolution. If you are going from angular to revolution, you would go 1 revolution divided by 2 pi radians. Okay? So there's that one. Then, the next one that we have is linear speed. So now again, we're talking how fast is that valve stem traveling. Okay? So when you're going slower, obviously it's not going as slow. When you're going super duper fast, obviously the speed is greater. Okay? So that we're talking about those two. And in this one, it's not a very easy conversion because it's not always going to be 1 revolution is 2 radians. Here, 1 radian is equal to 1 radius. Okay? 1 radian is 1 radius. Okay? So if we're going from angular to distance, we would take that radius divided by the radian. If we're going from linear to angular, we would have radian divided by radius. Okay? And then lastly, what we can come out of the speed chart is we can come out with total distance that the object traveled. Okay? So if I spin this valve stem around and I stop it, it's spinning around and around and around and around, and there it just went 8 feet. Okay? The valve stem traveled a total of 8 feet. Whereas if we had flipped the bike over and we were spinning on it, how many revolutions it would take to go 8 feet, etc. In order to find that one, we have to, if we're going down, we multiply by time. If we're going up, we divide by time. Okay? Let's put these to work. Very helpful for you going forward. So, a truck wheel with a diameter, a truck wheel with a diameter of 36 inches rotates at 630 revolutions per minute. Find the speed of the truck in miles per hour. One of the nice things that for some reason students don't pick up on is the fact that we will give you a certain speed or quantity, let's say. And in this particular case, we are giving you 630 revolutions per minute. That is a rotational speed. But I also gave you what the answer needs to be in. I'm also telling you that the answer needs to be in miles per hour. So you're going to factor label this problem until the only two things that you have left are miles and hours. If you don't have miles and hours at the end of your problem, you aren't done yet. You haven't gone far enough. Okay? You know when to stop when you got miles per hour. Okay? So we start out with 630 revolutions per minute. RPM is revolutions per minute. Okay? We need to get revolutions into miles. We need to get minutes into hours. Which one would you like to start with? Revolutions? Okay. All right. So if I'm going to take my revolutions, according to my speed chart, I'm way up at the top in rotational speed. First, I got to go to angular speed. Well, angular speed says that I'm going to take one revolution is 2 pi radians. Oops. Now I can cross out my revolutions. So now I'm in radians per minute. Still not in miles yet. Okay. 1 radian is how many inches? Or what is the radius of the truck tire? Ms. Bailey? 18. Why is it 18 and not 36 as everybody so quick was to answer? 36 is the diameter, not the radius. So the radius is 18 inches. Now I'm in inches per minute. Need to get inches into miles. What would we like to go with next? Into feet? Okay, sounds good. 12 inches is 1 foot. And 1 foot is how many miles? Or how many miles are in one, saying that wrong. How many feet are in 1 mile? 5,280. Yes. For those of you that didn't notice, on the back board, there is the stuff you should know board now. Great. Whoa. Feet are gone. Inches are gone. Now I'm in miles per minute, correct? So I need to convert minutes now because I have miles. How many minutes are in 1 hour? My only label that I have left that I can see on top is miles. That's what I need. My only label that I can see on the bottom is hours. That's what I need. Miles per hour. Now I just have to multiply all of those fractions. 630 times 2 pi times 18 times 60 is my top. 11112 times 5,280 times 1. My question to you is this. Does this fraction need to be exact? I'll pose a secondary question, a follow-up question if you will. When you drove to school this morning and looked down at your speedometer to make sure that you were only doing 25 miles an hour as you got closer to school, was it 25 miles an hour on your speedometer, or was it 8.3 pi on your speedometer? It's 25, right? Okay. So do we need to be exact for this one?
Yeah.
No. Find me what it is.
What? Oh, never mind.
I get 67.473 miles per hour. Uberly important question. What if I don't put the label? It is wrong. Okay? It is wrong. Labels in the speed unit that we're doing here in 4.1, super duper important. Okay? Questions, comments, concerns, clarifications? You got a bike tire racing. Find me how many revolutions per minute the wheels are making. Go. Inches times yes. Okay, so we're at 36 feet per second. We need to be in revolutions per minute. So the first thing that I'm going to do is I'm going to say that there are 60 seconds in 1 minute. Okay, so that's gone. So now I'm at least in, now I just got to take feet and make it into revolutions. Okay, my diameter is in inches. So therefore I am going to need to first convert 1 foot into 12 inches. One foot is now 12 inches. Okay? Now I can go, or I can say that 14 inches is 1 radius, which means it's 1 radian. So now I'm in radians per minute. Then I can say that correction. I can say that 2 pi radians is 1 revolution. And now I'm in revolutions per minute. So on top I get 36 times 60 times 12. On the bottom, I get 14 times 2 times pi. And when we do that, in your calculator, and I will wait for you to yell at me. And then I will say, no, no, no. I get 294.664 revolutions per minute. Lay it on me.
What's wrong then?
Nothing. That's the right answer.
Oh.
Some people are scared to say that they got 2,096. Did you? Okay.
I didn't do it the way you did it.
Okay. How'd you do it?
Well, I converted the 36 feet to inches right away.
Okay.
I put 432 over 1 second times 1 radian over 14 inches.
Okay.
And then, which I guess makes it the same. And then I just put 6 times 1.
I'm in. But yeah, where would we got? So everything worked. It doesn't matter. You converted your feet into revolutions first. I converted my minutes into, or my seconds into minutes first. Yep. Where would we screw up and we'd get 2,096?
In the calculator.
In the calculator. Where? How? With pi. Right here, if you just typed in divide by 14, divide by 2 pi, and you don't put parentheses around the 2 and the pi, it's going to divide by 2, and then it's going to multiply by pi. Caitlin, just so you know, I'm this way. That's why we have desks there, so that you face this way, not face that way. Yeah. Yeah. There's a reason we did everything. That's why we didn't put a chair there. Yeah. Okay? You guys ever wondered how fast your laundry's going in the washing machine?
Never. I have never wondered that. Once in
Okay. Or how far it goes?
No.
All right. I'm going to give you guys 9 minutes to answer those 2 questions.
2. In 1 mile, which equals, the answer is, do I really want to type this in now?
Your mile. Yes.
Let's be, okay. Well, he's in the west, so this is not far.
15 minutes.
I can't read the first part of the question. I can see.
How far does a sock travel in 15 minutes?
Okay, so so it would be this number 62.564 miles per hour.
How is it that?
Miles per hour. That's the labeling on it. Because that's what you got over here.
Oh, in 1 hour.
Yeah. So then you're gonna want to go from hour to minutes, right? 1 hour, 60 minutes. Right?
Yeah, but then you gotta do it to 50.
So then you'd put minutes on the top, right? 15 minutes.
So then you go from
Divided by total distance divided by.
How fast is your sock traveling?
88.56.
Good thing there's not a flux capacitor inside your washing machine.
Wait, what's 60 divided by?
Great Scott. Exactly. Okay, everybody good on 88.547 miles per hour?
And now,
What?
Wait, what?
that is not even close.
Forgot to do my
That is
cross outs.
divided by 12.
That's fine.
So take that number.
Okay. Then, what's up?
Does it have to be like 3 decimal places after?
Typically we go 3. Yeah, and like on the test, I think we say if we say it's a rounding problem, it's rounded to 3.
Feel safe if it's a running problem.
Okay. So then my next one, just because I don't,
No.
I don't ever round, I always use exact, and then just round at the end.
This is college. Or not.
So we're starting back there, okay? Because that gets me my 88.547 something, and then I got to multiply that by, now this is in miles per hour. Well, 15 minutes is 1 hour is 60 minutes. Now I'm in miles per minute, and then I can multiply that by 15 minutes. And that just leaves me with miles. So in that 15-minute spin cycle, that sock traveled 22.137 miles. Can you see why doing the laundry is not good for your clothes? I mean, it gets them clean, obviously, but that's why they get worn out.
Would you mark around a test if we like showed the work and did the miles per hour times 15 divided by 60?
No. I could also do, because 15 minutes, you could also have done here, instead of doing this way right here, you could have done, because 15 minutes is 1/4 of an hour. Yep, so 1/4 hours.
Cancel that.
Yep, and then that cancels out the hours. As long as I can see what your logic is, and you're not making up your own math, I'm okay with it. Okay?
We're done. That's weird.